So let's now take a look at gradient descent. This lesson will be rather technical on the math side, but I will be able to give you good intuition, because it's important that you understand what is going on. I plotted here the cost function versus the weight, and we've seen that the relationship is quadratic. And this is typical a quadratic relationship, this shape here. Okay? So what we're going to do is we start at a certain point W0. And I'm going to draw a little man here at that point. So we start, pick W0. Okay? And then in W0, what are we going to do? Well, we're going to calculate the derivative in that point. Remember, it's a tangent line to the shape, and that's the derivative. So we're now going to look at the sign of the derivative, the sign of the derivative in that point W0, and that sign that is negative. Negative meaning we're going downhill, so we're walking in the right direction. So that person here, he now takes a step in the right direction. Assume that he takes a step to here, then here we're going to do exactly the same. This is W1, and this is of course the cost in the point W1. So sign is negative, then we take a step in downhill direction. Yeah? And then you do exactly the same. You again calculate the derivative in that point. And this is something like this. Yeah, so then you look at the sign of the derivative in the point W1, and here again we see that this sign is negative. So we're confirmed that we're going into the right direction, and this guy will do this repeatedly, so that we repeat this. We'll repeat until dC dW, in a point I would call W minimum, is close to 0. Yeah, so that's basically the line here. And here that line shows us that we found the W minimum, or at least we're very close, at the weight W minimum that minimizes my cost function. Okay? So that's basically it. Gradient descent is a man walking downhill. Every time you take a step, you calculate the derivative, and the sign of the derivative will guide you. Will guide you in terms of what direction you need to walk. So in general, oh, and here before I continue, remember this graph where we had inputs and outputs. The outputs also called the label, label. Inputs called features. Yeah, and the computer is training and finding the model that best maps inputs to outputs, and so the outcome is the model. So the training is actually exactly what we're doing here. We pick first a W0. Yeah, we look at the sign of the derivative. If negative, we're going to take a small step. Then we have W1 all the way down to when we reach W minimum, and when we found W minimum, that is when the computer will output the model. Okay? So the general update rule for gradient descent is Wi plus 1. So that is the next iteration equals Wi is the current iteration minus alpha dc dw in the current point Wi. So that is my update rule for gradient descent. So if I equals to 0, what do we have? We have W1 equals W0 minus alpha dc dw in the point W0. Okay? Now, dc dw in the point W0, this is negative. So, but this negative and this negative together make a positive. So that gives you that W1 equals W0 plus something positive. And that's exactly what you see. So you go in that direction. Because you're going to add something to W1 to W0 to get to W1. Now, if we would have started on this side, we would have gotten exactly the same solution. On this side, your derivative is going to be positive. And then with the minus here, then it says W1 equals W0 minus something positive. Yeah? So that means you go in this direction. Now, alpha here is called the learning rate. And alpha is a hyperparameter, which means that we as data scientists need to choose alpha. So alpha is a hyperparameter. And we'll see a lot of hyperparameters in machine learning. Yeah? So, how to choose alpha? Well, obviously, when alpha is too small, then we're going to have slow convergence. Yeah? Slow convergence because, you're going to take so many steps downhill that it will take you a long time to get to the minimum. So we can't choose alpha too small. But if alpha is too big, then there is no convergence. We will have oscillations. Yeah? And the way to picture this is rather simple. You have a person here walking downhill, so if the step he takes is too big, then the person is going to end up here. Right? So he's going to overshoot the minimum. Yeah? So we go from here to there. Here the same, he takes a step of the same size, he's going to bounce back here, and there. So he's going to oscillate between the two. That means alpha too big, oscillations, no convergence. So what is the best value for alpha? Well, Andrew Ng, in his video series, he said start with alpha equal to 0.001, then do times 3, 0.003, and then do again times 3, 0.01. You do always times 3 until you get to 0.1. That's guidance Andrew Ng is giving. Okay, so I don't think it was very complicated. You understand now that we are in a training phase, and the training phase means that the computer is trying to build a model with the lowest cost. And once we found that minimum, we give the model. And the model then allows us to predict stuff based on new data.